Welcome to my class. In today's video, I am going to describe and explain diffusion in terms of kinetic particle theory, describe and explain the effect of relative molecular mass on the rate of diffusion of gases. Diffusion in fluids. So in the diagram, you can see a crystal of potassium permanganate is put into this container of water. This diagram represents the arrangement of water and crystal particles in this beaker. When a crystal of potassium permanganate is placed in water, the water around the crystal becomes purple. Eventually, the crystal dissolves and the whole solution becomes purple. This is due to a process called diffusion. This process can be explained in terms of kinetic particle theory. The particle leaves the crystal and collides with the water particles. As a result, the particle bounces in all directions. Eventually, the crystal particles become evenly spread throughout the water. Diffusion in gases. In this glass jar, a drop of bromine water was added. After some time, the glass jar was completely filled with the vapors of bromine. This diagram represents the arrangement of air and bromine particles. The particles of bromine mix with the air particles due to the collision between the particles. The particles bounce in all directions. This process continues until the bromine particles are evenly spread. Definition of diffusion. Diffusion is the movement of particles from a region of higher concentration to a region of lower concentration until the particles are evenly spread. Note: diffusion does not take place in solids. Diffusion in gases is faster than diffusion in liquids. All substances do not diffuse at the same rate. Comparing the rate of diffusion of two gases. In the diagram, you can see a long glass tube which is closed on both the sides, and on the left hand side you can see a cotton wool soaked in ammonia solution, and on the right hand side you can see a cotton wool soaked in hydrochloric acid. Cotton wool soaked in ammonia, relative molecular mass equals 17, is put into the left end of the glass tube. Cotton wool soaked in hydrochloric acid, relative molecular mass 36.5, is put in the right end of the tube. The tube is closed. The colorless vapors of the substance diffuse and meet at a point near the right end of the tube. Ammonia and hydrochloric acid react when they meet to form a white smoke of ammonium chloride. Ammonia particles, which are lighter, travel greater distance than hydrochloric acid particles in the same length of time. Result: diffusion depends on the relative molecular mass of a substance. Lower the molecular mass, the faster the diffusion. Thanks for watching the video. I hope you found my video useful. Please like, subscribe and share.